Hello and welcome to VideoTec. In this month's program, we'll be looking at the 3-liter engine available on Premier and Monaco models. The 3-liter engine is a wet sleeve V6 that has some unique features and requires special service procedures. We'll begin by looking at some of the design features exclusive to the wet sleeve engine. And then we'll perform an engine overhaul procedure involving engine disassembly, cylinder sleeve, and piston replacement. And then finish by reassembling the engine, highlighting the cylinder head bolt tightening procedure. Now to begin, let's take a look at the design of the wet sleeve engine. Unlike a conventional engine with a cast iron or aluminum block, the 3-liter engine on Monaco and Premier models uses an aluminum block with removable piston sleeve assemblies. This design allows efficient cooling of the cylinders because coolant can flow unrestricted around the outside surface of all cylinder sleeves. Efficient cooling is just one feature of the wet sleeve design. The design allows the use of hard-wearing liners in an aluminum block. This gives a lightweight engine without sacrificing durability. Another feature, if the cylinder is damaged, the wet sleeve design allows the replacement of an individual cylinder liner and piston. On a conventional engine, if the single piston is damaged, it often means that all the cylinders must be rebored and the pistons replaced with oversized pistons. Also, the cylinder sleeve, piston rings, and connecting rod pin come in a matched set, allowing precision clearances to be maintained. As already mentioned, the design of the wet sleeve engine requires some special procedures to service it. Now, you'll find these procedures in 2 publications you may already be familiar with: the 1990 Premier and Monaco Service Manual and the 3-liter V6 engine overhaul student reference book. Now, when we come back, we'll go through the procedure outlined in these manuals for the removal and replacement of a cylinder sleeve and piston assembly. For the purposes of this program, we'll be showing the sleeve liner and piston replacement procedure with the engine removed from the vehicle. Now, if you need to remove the engine from the vehicle to replace the cylinder liners or to disassemble the engine, be sure to follow the procedure described in Section 9 of the 1990 Premier Monaco Service Manual. Before removing the engine from the vehicle, make sure that you remove the drive plate, drain the engine water jacket by removing the drain plugs from the sides of the block, remove the exhaust manifolds, and remove the oil filter, and thoroughly drain all oil from the engine. It's important that you fully drain both oil and coolant to avoid coolant contamination of the oil galleys or oil contamination of the water jacket. With the engine attached to the engine stand, you're ready to begin. Now, let's have our technician take us through the procedure. Begin the engine teardown by removing the intake manifold. It's held down by these 4 bolts. Remove the bolts and lift the manifold up and away from the engine. With the manifold removed, you'll be able to see the O-rings located in these grooves around the intake port in the cylinder heads. The O-rings seal the 2 mating surfaces. The O-rings must be replaced whenever the intake manifold is removed. Use a pick to remove them, then discard the O-rings. The next item to be removed is the water pump and Y-tube assembly. To do this, remove the water pump retaining bolts. Now, you'll need to use a box end wrench to loosen the lower bolt. The bolt stays with the pump as it's removed. If you experience difficulty loosening the lower bolt, you can either remove the water pump pulley using puller tool number 6160 or use a specially bent wrench. Then disconnect the hoses at the cylinder heads. Remove the Y-tube retaining bolts and remove the water pump and the Y-tube as an assembly. Remove the Y-tube O-ring seals and discard them. Again, you should never reuse the O-ring seals. Now, with the water pump and Y-tube assembly removed, the next step is to remove the cylinder head covers and gaskets. The cylinder head covers are held down by 10 bolts per side. During the procedure for replacing the sleeves and pistons, it will be necessary to position the crankshaft. Now, if the timing case cover is to remain on, you can use the crankshaft pulley nut to turn the engine. If the timing case cover is to be removed, you'll need to install crankshaft turning tool number 6072 at this stage of the procedure. Now, to gain access to the piston sleeves, we first have to remove the cylinder heads. If you haven't already, now is the time to remove the spark plug wires and the spark plugs. Next, completely remove the timing case bolts that thread into the cylinder heads and loosen the timing case bolts below the cylinder heads, one turn. It's very important that the timing chain and sprockets be held in place while the cylinder heads are removed. If the chain and sprockets are allowed to slip, you'll have to remove the timing case cover, readjust the timing chain assembly, and retime the engine. Chrysler has a special tool to hold the chain and sprocket while the heads are removed. Chain and sprocket support tool number 7317, which consists of a support bracket and a dummy bearing. If you're going to remove both left and right-hand cylinder heads, you'll need two of these tools. Now let's watch as our technician demonstrates how to install them. First, remove the bolt and adjusting lever from the support bracket. Then rotate the crankshaft until the dowel in the camshaft sprocket is straight up. Attach the support bracket to the top of the timing case cover, under the timing chain, and against the camshaft sprocket. Use the two short cylinder head cover bolts to secure the bracket to the timing case cover. Position the adjusting lever behind the camshaft sprocket and thread the bolt through the front of the tool, through the hole in the sprocket, and into the lever. Push the lever up as far as possible, then tighten the bolt. On the right-hand cylinder head, you'll need to unthread the plug in the front of the timing case cover to gain access to the camshaft sprocket bolt. On the left-hand cylinder head, you'll first need to remove the distributor cap, the rotor, and the dust cover. If you haven't already, pull the distributor wires and, if necessary, remove the distributor cap shield. Completely loosen the distributor cap screws. Remove the mounting screws attaching the rotor to the distributor drive. Then remove the rotor and the dust cover. Attach the support bracket to the top of the timing case cover, under the timing chain, and against the camshaft sprocket. Use the two short cylinder head cover bolts to secure the bracket to the timing case cover. Position the adjusting lever behind the camshaft sprocket and thread the bolt through the front of the tool, through the hole in the sprocket, and into the lever. Push the lever up as far as possible, then tighten the bolt. Next, remove the camshaft cover and gasket at the rear of the cylinder head. Loosen the camshaft thrust plate screw, pull the plate up, and tighten the screw. This will allow the camshaft to move back as the sprocket screw is removed. It's important to attach a wrench or socket to the crankshaft pulley nut to prevent the crankshaft from turning while removing the camshaft sprocket bolt. Then, when you are certain that the crankshaft is securely prevented from turning, use socket wrench tool number 7399 or a 10mm hex drive socket to loosen the camshaft sprocket bolt. In order to break the camshaft loose on the left-hand cylinder bank, it may be necessary to replace the camshaft sprocket bolt and tighten a few turns. Then lightly tap the sprocket bolt with a mallet until the camshaft breaks free and moves backward. To move the camshaft on the right-hand cylinder head, you'll first have to remove the timing case cover plug and then pull the camshaft rearward while loosening the sprocket bolt until the bolt is out of the camshaft. The bolt will stay in the sprocket hole. It will not drop down because the timing case cover is too close for it to come out of the sprocket. Now, when the sprocket bolt has been completely removed, pull the camshaft back and away from the camshaft sprocket. Our technician is now ready to remove the cylinder head. Remember that on the 3-liter engine, the bolts holding down the rocker arm shaft assembly also hold down the cylinder head. The rocker arm assembly is held down by 8 bolts. A word of caution: never use an impact wrench to remove the cylinder head bolts. This will damage the threads in the aluminum cylinder block. Use hand tools to remove the cylinder head bolts. Then remove the rocker arm shaft assembly from the cylinder head. A word of caution: the lash adjusters on newer engines may fall out when the rocker arm assembly is removed. To prevent this, After loosening the cylinder head bolts, use a rubber band to hold each lash adjuster in place on its rocker arm. When removing the rocker arm assembly, note that the pins in the bottom of front and rear pedestals index the assembly to the cylinder head. You may need to pry on the underside of the pedestal front and rear to remove it. Never hit the assembly with a hammer or mallet to loosen it. To prevent the cylinder head from falling off the block, install one cylinder head bolt into a center hole and tighten about halfway. Insert an old push rod ground flat or a long thin drift punch into the front and rear cylinder head bolt holes on the exhaust manifold side. Tap the cylinder head gasket alignment dowels down below the head gasket. We're now ready to remove the cylinder head. It's important that you do not pry or lift the cylinder head straight up from the block, as this may cause the cylinder liners to come up and out of the block. Position a small block of wood against the intake manifold side of the cylinder head and strike it with a mallet. Now position the wood block against the exhaust manifold side of the cylinder head and strike with the mallet. Repeat this procedure until the cylinder head breaks loose. Remove the cylinder head bolt, remove the cylinder head, and stuff the tops of the cylinder bores with clean, lint-free shop towels. Then remove the cylinder head gasket. Another caution: never use a metal scraper to clean the cylinder head and block mating surfaces. The surfaces could be cut or grooved. Instead, use a wooden or plastic scraper. Another important tip: while working on the engine, make sure the gasket or other foreign material does not enter the oil feed hole or the oil return hole. Be sure to plug the oil feed and oil return holes with a vacuum nipple or similar object. Use a gasket removal compound to soften the old gasket material. Rinse and wipe clean the cylinder block and cylinder head mating surfaces. The dummy bearing is installed next. It's held down by two short mounting bolts. Replace the camshaft sprocket bolt and snug it tight. Then remove the support bracket. Finally, install liner clamp tool number 7315 between the cylinder liners to hold them in place. If the piston liner assemblies will be reused, reference the piston to cylinder liner to cylinder block position using a grease pencil. With the cylinder heads removed, the next step is to disassemble the connecting rods from the crankshaft. To do this, we need to further disassemble the cylinder block. Begin by removing the oil pan, inlet tube, and baffle. Rotate the engine on the stand until the oil pan is pointing straight upward. Remove the oil pan bolts and washers. Then remove the oil pan. It's a good idea to wear cotton gloves while doing this to prevent cuts on the sharp castings. Clean the old gasket material from the lower casing. Remember, never use a metal scraper to remove the gasket material from the lower casing. It could cut or groove the casing. Instead, use a wooden or plastic scraper. Now the oil pump inlet tube is next. It's held down by these four mounting bolts. Remove the mounting bolts, then remove the inlet tube. Remove the O-ring seal and discard the seal. The oil baffle is removed next. First, remove the oil baffle mounting bolt. Remove the remaining bearing mounting bolts, then remove the oil baffle. Mark each connecting rod and cap with the cylinder number on the side that faces out. This is to ensure that the caps can be installed with the correct connecting rods. When loosening the connecting rod nuts, loosen the nuts of both connecting rods at each journal before removing either one of the connecting rod piston liner assemblies. Loosen the necessary nuts. You'll have to rotate the crankshaft to provide access to all of the connecting rod nuts. The piston should be at the bottom of the liner. Remove the liner clamp tool number 7315 from the cylinder block. Have an assistant hold the liner assembly in place. A note of caution: when removing the piston liner, care must be taken so that the connecting rod bolts do not nick or scratch the crankshaft journal. Make insulators out of short lengths of rubber hose and slip them over the connecting rod bolts once the cap is removed. Remove the piston liner assembly. Repeat this procedure on all other piston liner assemblies that need to be replaced. Next, remove and set aside the liner seal. It's important that you never reuse the liner seal. When you have removed all the piston liner assemblies that need to be replaced, the liner clamps, tool number 7315, should be replaced. Remove the piston connecting rod assembly from the bottom of the liner. For now, set the components aside on the bench. Clean the cylinder liner seat. Remove all deposits from the seat and from the water jacket walls of the cylinder. Now that you have the old cylinder liners and pistons out of the engine, the next step is to replace them. Replacement cylinder liner kits are available through the parts system. Each kit contains one of each component: cylinder liner, piston rings, piston pin, and the piston. The components of these kits are pre-measured and matched to ensure correct clearances. When you remove the components from their bag, you may notice that they are coated with a preservative. The preservative can be removed with acetone. Do not try to scrape the coating off any component in the kit. In some cases, the kits will come with the piston installed in the new cylinder liner, with piston rings already in place. Be sure to remove the new piston from the bottom of the cylinder liner. The top of the liner is not chamfered. Do not remove or install the piston from the top of the liner because damage to the piston rings and ring lands can occur. Mark the components of each kit with the same letter so that they are not mixed with another kit. For example, if 3 kits are used, mark all components of the first kit with the letter A, the second kit with the letter B, and so on. Now, let's look at the procedure for installing new cylinder liners and liner seals. A steel cylinder liner seal is used to seal between the liner and the cylinder block. When the cylinder liner and liner seal are installed in the cylinder block, the top of the liner should protrude above the cylinder block deck. The amount of protrusion needs to be within set specifications. Now, to find the correct protrusion specification for your engine, check the engine identification number. On engines with serial numbers starting before 59230, the identification tag is attached to the right-hand side of the cylinder block, below the exhaust manifold. On engines starting with engine number 59230, the engine ID plate was relocated to the right side engine bank under the intake manifold. This was a 1989 vehicle production running change. On all engine ID plates, the first 6 digits identify the engine type. The second row of digits identifies the numerical sequence of engine build. Vehicles built for Tennessee have an additional number stamped behind the right-hand side engine mount bracket. The number used is the final line building sequence, followed by the last 2 digits of the model year. The number starts and ends in an asterisk to prevent alteration. Once you have the engine number, check the service manual or student reference manual for the correct protrusion specifications for your engine. In our case, the service manual lists a protrusion specification of 5 to 8 thousandths. It's better if the amount of protrusion is at the higher end of the tolerance. To adjust the amount of protrusion, you can use different thickness cylinder liner seals. The liner seals are available in 3 thicknesses and are identified by color code. Now, if the original cylinder liner piston and connecting rod are being reused, be sure to measure the old liner seal and use a new liner seal with the same thickness. And be sure to install the old liners in the same bore from which they were removed. Align the marks that remain on the cylinder block and liner when the engine was disassembled. If a new cylinder liner assembly is used, place the new liner with the silver-colored liner seal into the cylinder block. Since the liner is new, no special alignment procedure is required. The next step is to check the liner protrusion using the support block tool number 6295 and 6296 and a dial indicator. Check 3 or 4 locations. If necessary, rotate the cylinder liner in the bore to even out the readings. Adjust the liner protrusion so that the amount of protrusion is greatest at the number 1 position on the left bank and the number 4 position on the right bank. Protrusions should step down in small increments from the number 1 and number 4 cylinders. You shouldn't have a difference in protrusion between any two adjacent cylinders greater than 1.5 thousandths of an inch. When the liner is set to the correct protrusion, mark the liner and the cylinder block so that the liner can be repositioned. Then remove the liner. The next step is to replace the piston connecting rod assembly in the cylinder liner. Connecting rods are not part of the kits. If the old connecting rods are to be reused, the piston pins will have to be pressed out and the new pistons installed. In most cases, you'll probably have your local machine shop do this. However, we'll give you an overview of that procedure. The first step is to press the old piston pin out of the connecting rod. The new piston and piston pin are assembled onto the connecting rod by heating the small end of the connecting rod on a hot plate until the piston pin bore expands. The pin is then quickly pushed through the piston and the connecting rod. As the small end cools, the pin bore contracts, forming an interference fit with the piston pin. With the piston and connecting rod assembled, the next step is to install the assembly into the new cylinder liner. Now, ordinarily, cylinder liner piston kits come with the piston rings already installed on the piston. If, however, you had to replace the piston rings, remember that the piston ring end gap has been preset to the cylinder liner. There's no need to trim the ring ends. Also, keep in mind that the oil scraper ring is U-flex designed and can be installed with either side up. The scraping edge of the second compression ring is tapered and must be installed with the side marked top facing up. The scraping edge of the top compression ring is not tapered and can be installed with either side up. Install the rings with each end gap 120 degrees apart from each other. A caution: the top of the cylinder liner is not chamfered. Do not install the piston from the top of the liner because damage to the piston rings and ring lands can occur. The piston must be installed from the bottom of the liner. Lubricate the piston, piston pin, and cylinder liner with clean engine oil. Making sure that the piston ring end gaps are 120 degrees apart, put the piston connecting rod assembly in the piston ring compressor and install the piston into the cylinder liner from the bottom. Now, before installing the piston liner assembly into the cylinder block, slide insulators made from rubber hose over the ends of the connecting rod bolts to prevent nicking the crankshaft journals. Install cylinder liner piston assemblies 1, 2, and 3 on the left bank of the engine, with the arrow on the crown of the piston pointing toward the crankshaft pulley end, and the shoulder of the connecting rod pointing to the flywheel end of the engine. Be sure to align the marks on the cylinder liners with those on the cylinder block. Install cylinder liner piston assemblies 4, 5, and 6 on the right bank of the engine with both the arrows on the crown of the piston and the shoulder of the connecting rod facing the crankshaft pulley end of the engine. Remember that connecting rod caps cannot be interchanged between connecting rods. Also, make sure that the cap is the right way around when installing it on the connecting rod. Install the connecting rod caps and finger tighten the connecting rod nuts. Note, do not tighten the connecting rod nuts until all cylinder liner piston assemblies are installed. Install liner clamp tool number 7315 to hold the liners in place before installing the next assembly. When all the cylinder liner piston assemblies are in place, tighten all connecting rod nuts to 33 foot-pounds of torque. Use a feeler gauge or magnetic-based dial indicator to check the connecting rod's side clearance at each journal. The side clearance must be between 8 and 15 thousandths of an inch. Reassembling the 3-liter engine is simply a matter of reversing the disassembly process. Now, there are some points to pay particular attention to. For example, any place where you removed an O-ring seal, always replace it with a new O-ring. Never try to reuse a seal. The same goes for gaskets on the oil pan and oil pan drain plug. Bearing those points in mind, let's watch as our technician takes us through the assembly procedure, beginning with the oil baffle. Now, when installing the oil baffle, first finger tighten all the bolts. Then use a torque wrench to tighten the oil baffle mounting bolt to 9 foot-pounds of torque, and torque the remaining bolts to 13 foot-pounds of torque. Install the new O-ring seal on the bottom of the oil pump inlet tube. Install the oil pump inlet tube. Then use a torque wrench to tighten the mounting bolts to 9 foot-pounds of torque. Install dry the new oil pan gasket to the lower casing. Then install the oil pan and use a torque wrench to tighten the mounting bolts to 9 foot-pounds of torque. Then install the oil pan drain plug using a new gasket or washer and tighten the plug to 22 foot-pounds of torque. With the bottom of the engine assembled, the next step is to replace the cylinder heads. Remember that the cylinder head gaskets are not identical. The left-hand gasket has a larger cutout at the front than the right-hand gasket. Also, engines starting with the engine number 89616 use a different gasket that is not interchangeable with engines that have engine numbers prior to 89616. Rotate the engine on its stand until the left bank is pointing straight up. Rotate the crankshaft until the keyway slot is pointing straight up. This will position the number 1 piston below top dead center and prevent contact between pistons and valves. The first step is to use dowel extractor tool number 7314 to pull the cylinder head dowels back up. Simply insert the tool like so and use the slide hammer to tap the dowel back out of the block. Then insert a nail or a 3mm pin punch into the hole in the block immediately below the locating dowel, and tap the dowel back down until it just contacts the pin punch. Remove the cylinder liner clamps from the left-hand cylinder bank. Replace the adjusting lever on the support bracket tool and remove the dummy bearing. Place a bead of RTV sealant on the timing case cover to cylinder head joint. Then install dry a new cylinder head gasket to the left cylinder bank. Never use spray gasket sealant, as this will destroy the head gasket's ability to maintain a proper seal. Then position the cylinder head over the new head gasket. It's a good idea to install one of the head bolts to prevent the cylinder head from falling off. Push the camshaft forward toward the camshaft sprocket. Make sure you align the slot on the cam with the dowel on the camshaft sprocket, and keep pulling the camshaft forward while tightening the sprocket bolt using socket wrench tool number 7399. Once again, it's important to attach a wrench or socket to the crankshaft pulley nut to prevent the engine from turning while tightening the camshaft sprocket nut. Loosen the camshaft thrust plate screw, push the plate down, and tighten the screw. Install the camshaft cover with a new gasket at the rear of the cylinder head. Coat the mounting bolt threads with Loctite 242 blue and tighten them to 48 inch-pounds of torque. Next, install the rocker arm shaft. Note that the pins in the bottom of the front and rear pedestals index the assembly to the head. Now, because of the springs separating the rocker arms, you may find it necessary to slightly compress the assembly before the pins will line up. Now, remove the 3mm pin punches. Lightly oil the threads of the cylinder head bolts, and then install them in the cylinder head. If you had to replace cylinder liners and pistons in both banks, you'll need to repeat this procedure for the other bank. The next step is to follow the cylinder head bolt tightening procedure. In the service manual or student reference manual, you'll find several different cylinder head bolt tightening procedures depending on the engine serial number. We will only be showing the procedure used on engines up to and including serial number 89615. Be sure to check the serial number of your engine and then refer to the manual for the correct tightening sequence. Starting with the number 1 bolt in the sequence, pre-tighten all bolts to 44 foot-pounds of torque. The following procedure is then performed on all bolts one at a time. Starting with bolt number 1, completely loosen all bolts. Then tighten bolt number 1 to 15 foot-pounds of torque. Install the graduated disc tool number 7321 or equivalent between the socket and the wrench. Set the tool to 106 degrees and then angle tighten bolt number 1 to 0 degrees, plus or minus 2 degrees. Repeat the procedure for all remaining bolts in the sequence. For 1990, new torque-to-yield bolts were introduced as a running change. One way to tell if the engine you're working on has torque-to-yield bolts is by a visual inspection. Torque-to-yield bolts have a thread depth roughly twice that of a regular bolt. It's important never to mix regular bolts with torque-to-yield bolts. If your engine does have torque-to-yield bolts, it's not necessary to run the engine, allow a 6-hour cool down, and then retighten the head bolts. With the head bolts tightened, we can go ahead and finish rebuilding the engine. Remove the chain and sprocket support tool and replace the timing case cover to cylinder head bolts. Don't forget to tighten the remaining timing case bolts. Install the distributor drive bolt and tighten the bolt to 59 foot-pounds of torque. The cylinder head covers are next. Once again, remember that the right and left cylinder head cover gaskets are not identical. Before you install a new cylinder head cover gasket, apply a dab of RTV sealer at the timing cover to cylinder head mating seams. Use new gaskets and install the right cylinder head and the left cylinder head cover. Tighten the mounting bolts to 9 foot-pounds of torque. Install the dust cover and rotor into the distributor housing and tighten the rotor mounting screws to 26 inch-pounds of torque. Install the distributor cap and tighten the mounting screws to 72 inch-pounds of torque. When replacing the water pump, remember to install 2 new wide tube O-rings into the top of the cylinder block. Install the wide tube and water pump as an assembly. Tighten the wide tube bolts to 9 foot-pounds of torque. Tighten the water pump mounting bolts to 13 foot-pounds of torque. Lastly, remember to tighten all hose clamps. The intake manifold is installed next. Install 6 new O-ring seals into the grooves around the intake ports of the cylinder heads. Install the intake manifold and tighten the mounting bolts to 9 foot-pounds of torque. When the intake manifold has been installed, the engine is ready to be reinstalled in the vehicle. Remember that certain engines will require the cylinder head bolt retightening procedure to be performed in the vehicle. As you can see, the wet sleeve engine has some unique features, but servicing it is relatively straightforward, providing you follow the correct procedures. Well, that's it for this month's VideoTec. In next month's program, we'll look at instrument cluster service on Premier and Monaco models.